In this lesson, we'll learn how to find the trig functions of angles that don't have reference angles that are equal to special angles of 30 degrees, 45 degrees, and 60 degrees. Consequently, we'll need our calculators. So let's look at some of these problems. Our directions say use a calculator to find a decimal approximation for each value, round to 4 significant digits. And for these problems, we're to find the sine of 85 6/10 degrees, the cosine of 52 degrees 38 minutes, and the cotangent of 163 degrees 26 minutes. I want you to notice something. This angle is in decimal degrees. This angle is in degrees and minutes, and this angle is in degrees and minutes. Whenever you're looking for a trig function of an angle that's in decimal degrees or degrees and minutes, you've got to make sure that your calculator is in degree mode. Now, you know there are a lot of different calculators on the market today, but basically they operate like just a regular scientific calculator or a graphing calculator. So I'm going to use these two types of calculators. For just a regular scientific calculator, when you turn it on, it's in degree mode. Now this one happens to say DEG right there to tell me it's in degree mode. For a graphing calculator, it's a little more complicated to get it in degree mode. We turn it on. This one has the mode button right here. Now, yours may not have the mode button in the same place, but it should have a mode button. And on this one, I have to come down to the third line. And on the third line, it says radian degree. Well, since my radian is highlighted, that means the calculator is now set for radian mode instead of degree mode. So we want to change it to radian mode. So I use my arrow down key and I arrow down to the third line, and then I use my arrow right key and I arrow over to degree, and you can see that over the degree it's flashing. And so if I go down now and hit my enter button, my calculator will be in degree mode. So we did that by hitting our mode button. We arrowed down to the line that said radian in degrees. We arrowed over to degree, and then we hit enter. To get back, we hit second and hit that mode button again, and that puts us back ready to use the calculator. And since we're here, let's go ahead and find the sine of 85 degrees, 85 6/10 degrees. And on this calculator, you have a sine button. So push your sine button, push your 85.6, and then push your enter button. So sine button, 85.6, and then enter. And you should get a value between -1 and 1, because sine values are always between -1 and 1 for angles other than the quadrantal angles. And we're supposed to round to 4 significant digits. That would be decimal 9971. Now, if we're using a scientific calculator, we're going to enter the angle first. And of course, when we turn it on, it's in degree mode. We'll do 85.6 and then hit your sine button. And you should get the same number. Now, on the second problem, the cosine of 52 degrees 38 minutes, the problem is that our calculator wants that angle in decimal degrees. and this is in degrees and minutes, so we'll have to convert degrees and minutes to decimal degrees, but we'll do that as we go. Let's work with the graphing calculator first. We'll push our cosine button, and then most of these calculators have a shortcut way to change degrees and minutes to decimal degrees. However, they all work differently. So rather than specialize on the calculator, I'm going to teach it a way that you should be able to do it on any graphing calculator. And if you want to know shortcuts, and incidentally some of them aren't that short, you can read your directions. But when I enter this angle, then I'm going to use parentheses, and then I'll enter the 52, and then I want to add to that, and this 38 minutes to get its decimal value means 38/60. So I'll go 38 divided by 60, and then I'll close parentheses, and so that will convert 52 degrees, 38 minutes to decimal degrees, and then I'll need to hit my enter button. So let's do that. Cosine, parentheses. On this calculator, the parentheses are right here. You'll just have to look and find your parentheses. And then the 52 plus 38 divided by 60, close parentheses, and push the enter, and we get a value of decimal 6069 rounded to 4 significant digits. Now, on the scientific calculator, since we put the angle in first, we're not going to need the parentheses. We can go 52 plus 38 divided by 60 and push equals, and that will convert degrees and minutes to decimal degrees, and then we can push our cosine button, and you should get the very same value. So try that. Alright, let's move to this third problem. What's special about this third problem is it's one of the reciprocal functions, and most of these calculators don't have reciprocal buttons. So we have to know a little trig here, and the little trig that we need to know is we have to know that the cotangent is the reciprocal of the tangent. So the thought is the cotangent of 163 degrees 26 minutes is the same as 1 over the tangent of 163 degrees 26 minutes. So what we will do with our graphing calculator is first we will find this tangent value, and then we'll use our reciprocal button. So to find that tangent value, hit your tangent button. We have to convert this angle to decimal degrees, so we'll use parentheses, 163 plus 26 divided by 60, close parentheses, hit enter, and let's do a checkpoint here. You don't really need to write this down, but let's be sure that we can do that. Tangent, parentheses, 163 plus 26 divided by 60, close parentheses, and push enter. And 163 degree angles in the second quadrant, so this should be negative. I got negative, And I'll just write the first 4 digits. I'm not going to worry about rounding because we just want to leave this in our calculator anyway. But that's what you should get when you do this line. Now we want to know what the reciprocal of that is, because the reciprocal of that's what the cotangent equals to. So if you hit your reciprocal button, which is x to the minus 1 on this calculator, all right, then if you hit enter, it automatically takes this answer and gives you the reciprocal. And so what we got here for a final answer is negative 3.362 rounded to 4 significant digits. Now, let's put the keystrokes for the scientific calculator. The thought here is still the same, but we'll have to put the angle in first, and so we'll go 163 plus 26 divided by 60 equals, and then we'll push our tangent button. So let's do that far and be sure that we have the right thing there. Let's see here. And sure enough, to this point, we have negative 0.2974, and it keeps going. And now we want the reciprocal of that. Now, on my calculator, the button is 1 over x. It could be x to the negative 1. Of course, those are the same thing. So all we need to do right here is hit that, and sure enough, rounded to 4 significant digits, you get negative 3.362. Now, let's look at some problems where we need to know a little trig before we use our calculators. It says simplify the expression before using a calculator to find the decimal approximation for each value, round to 4 significant digits. Well, in this case, it's much easier to simplify first because our calculator doesn't have a cosecant button. So what we're supposed to know is that 1 over the cosecant of 16 2/10 degrees is the same as the sine of 16 2/10 degrees. And so all of our calculators have sine buttons. So I'll let you use whichever calculator you prefer to calculate the sine of 16.2 degrees. We're supposed to round to 4 significant digits, and actually I got 0.27899, so when I round up, I'll have 0.2790. Now, when we look at this problem number 5, we could calculate that straight. We could say the sine of 65 degrees divided by the cosine of 65 degrees. But since they told us to simplify first, if I've got the sine of an angle divided by the cosine of an angle, in this case, I know it equals the tangent of 65 degrees, and then I can calculate the tangent of 65 degrees. And rounding to 4 significant digits, I get 2, 1, 4, 5. Now, look at this number 6. what they want us to do here is to recognize that we have the sine of 90 degrees minus an angle. They want us to use the cofunction identity. They want us to recognize that 90 degrees minus 10 and 8/10 degrees would give us the complement of 10 and 8/10 degrees. And since cofunctions of complementary angles are equal, instead of doing this, we could find the cosine of 10 and 8/10 degrees. And so, let's calculate the cosine of 10 and 8/10 degrees. And rounding, we get 0.9823. Did you remember that cofunction identity? If you've forgotten it, you might want to check out the tape that gives the lesson on the cofunction identities. Now we're going to use our calculators to solve trig equations. Now most books say things like find values of theta in 0 degrees to 360 degrees that satisfy the statement. I really like to say solve the equation for theta because look at it, it is an equation. The sine of theta equals 3,429 ten-thousandths. Anytime we solve an equation, we look for what we can replace the variable with to make this a true statement. And in this trig equation, theta is our variable. Now they're telling us to leave your answer in decimal degrees, so that means theta needs to be in decimal degrees. And if we want the calculator to give us degrees, then of course we know that it needs to be in degree mode. So make sure that your calculator is in degree mode, and it will give us the answer in decimal degrees then. All right. Well, the truth is that there are two values of theta that between 0 and 360 degrees that have a sine that's equal to 0.3429, and we'll need to find both of those. Our calculator will give us one value, but we'll have to use our knowledge of reference angles to find the other value. Now, before we actually work on the calculator, I'd like for you to look at your sign button, and it doesn't matter which type of calculator you have. Most of them have that sign button, and then what do you see above that sign button? Do you see, mine has SIN -1. Now that -1 symbol does not mean the reciprocal. And I know that you've learned anything raised to a -1 power is the reciprocal, but that doesn't mean -1 power here. It's like in algebra. When you have a function, when you are asked to find its inverse function, what symbol do you use? You use F, and then you have the -1. Well, that's what sine with the -1 there means. It represents the inverse function for the sine function. At any time that you are given the sine value and you are looking for the angle, you're going to use that inverse function. So let's work problem 7 using the graphing calculator. To get to your inverse sine function, since it's written down on the calculator above the sine button, you're going to have to use your second function button. Now, on most calculators, it's right here and it says second function, but I've seen that button called the arc button and the inverse button. So if you can't find the button, then once again I suggest that you read your directions. But most of them, this will say second and then you'll push your sign button, and anytime that you push your sign button after your second function button, it gives you the inverse sign, what's written down on the calculator, and then you'll need to put your value in, and then you'll need to hit enter. And you should come up with theta, and we'll round to the nearest tenth. I got 20.05, and rounding to the nearest tenth, it'll be 20.1 degrees. Now, let's do that on the scientific calculator, and then we'll talk about how to find the other angle that has a sine that's equal to 0.3429. On your scientific calculator, you're going to put your sine value in first, and remember that's a sine ratio, that if you had theta in standard position and you had a point on the terminal side, if you took the y coordinate of that point and divided it by r, you would get 0.3429. That's what that means. So put your 0.3429 in, hit your second, and then hit that sine button, which of course is your inverse sine, and you should get 20.1 also. So hopefully everybody's found the first quadrant angle. That's what your calculator gives you, is the first quadrant angle. Now we need to find the other angle. Now notice that this sine function is a positive 0.3429. So the other angle is going to be in a quadrant where the sine function is positive. Well, there are only two quadrants where the sine function is positive, the first quadrant and the second quadrant. So we'll be looking for the second quadrant angle that has a sine that's equal to 0.3429. Now let's think about this. What the 20.1 represents is the reference angle for the second quadrant angle. Do you remember from your special angles how the sine of 30 degrees was the same as the sine of 150 degrees? Because 150 degrees was a second quadrant angle, so it had a positive sine function, and because it has a reference angle of 30 degrees, well, the 20.1 degrees works the same. It is the first quadrant angle that has a sine equal to 0.3429. It is also the reference angle for the second quadrant angle that has a sine equal to 0.3429. So let's go back and figure which second quadrant angle has a reference angle of 20.1. All right, what we know is that all the way to here is 180, that the reference angle takes 20.1 degrees. So how will we find the second quadrant angle? And I'm going to use a little subscript, Roman numeral 2, to denote that this is the second quadrant angle. Well, the way we will find the second quadrant angle is we'll say 180 degrees minus 20.1 degrees. 180 minus that will give us what's left. And when we subtract it, we get 159 9/10 degrees. So the second quadrant angle that has a sine equal to 0.3429 is 159.9 degrees. So the answer to this question, what will make this a true statement? It will be true if theta equals 20.1 degrees and if theta equals 159.9 degrees. And you could check that. you could find the sine of 20.1 degrees on your calculator, and it should approximately be equal to this number. Now, it will be a little different because remember we have rounded right here. We had something else in our calculator. We rounded up to 1/10, and you should find the sine of 159 9/10 degrees, and when you do, it should approximately be equal to this number. All right, let's work another problem with a different trig function. For problem number 8, we know that the cosine of theta equals 0.5768. So since we're looking for theta, we'll use our inverse function. If we're working on a graphing calculator, we use our second function button first. Then we'll push the cosine button, which represents the inverse cosine, and it's written above the cosine button. And then we'll put our value in, 5768, and then of course we'll have to press our enter button. And that should give us theta. And we'll round to the nearest tenth. We get 54.8 degrees. And that represents our first quadrant angle that has a cosine that's equal to 0.5768. Now, if you're using a scientific calculator, you want to put your value in first, 0.5768, and then push second function button, and then push your cosine button, and of course that will represent the inverse cosine. And above the button on the calculator it should have cosine -1, and you should also get that theta equals 54.8 degrees. Now let's find the other value of theta that has a cosine that's equal to 0.5768. And first we have to think, since this is a positive number, which other quadrant has angles that have positive cosine values? It's the fourth quadrant, isn't it? And 54.8 represents the reference angle for that fourth quadrant angle. If you'd like to sketch a drawing, this would represent our fourth quadrant angle in standard position, and of course we know that this angle, the reference angle, is 54.8 degrees. So the way that we will find our fourth quadrant angle, since we know all the way around is 360 degrees, we'll say 360 degrees subtract 54.8 degrees. And what do you get when you do that? Did you get 305.2 degrees? All right, so if theta is 54.8 degrees, or if it's 305 2/10 degrees, if we find its cosine, we should get 0.5768. Of course, once again, you could check that, but remember that we did round to the nearest tenth of a degree, so it might not be exactly 0.5768, but it certainly should be close. All right, let's work that tangent problem. We know the tangent of theta equals 4.567. So to find theta using our graphing calculator, we'll go second function, press your tangent button. Since it's pressed after second function, that represents inverse tangent. Then your value, 4.567, and then your enter button. And we'll round theta, and rounded to the nearest tenth, it's 77 6/10 degrees. If you're using your scientific calculator, you want to put your value of your tangent function in first, and then use your second function button, and then hit your tangent button. And you should also get 77.6. after you round. Now the next thing we want to do is to find the other angle between 0 and 360 degrees that has a tangent that's equal to 4.567. And once again, the first thing that we'll do is determine which quadrant the terminal side of our angle is in. And we do that since 4.567 is a positive number. The other quadrant that has angles that have positive tangents would be the third quadrant. And so we know that that 77.6 is the reference angle for that third quadrant angle. So sketching that, that represents our third quadrant angle in standard position. 77.6 is the reference angle. So how are we going to find this third quadrant angle? Well, we know that from there to there is 180 degrees. So to find the third quadrant angle, we will add 77 6/10 to 180 degrees, and we get 257 6/10 degrees. So the other angle that has a tangent that's equal to 4.567 is 257.6 degrees. Now let's work some problems that involve the reciprocal functions of cosecant, secant, and cotangent. We are to find values of theta between 0 degrees and 360 degrees that satisfy the statement. Once again, another way to say this, since this is an equation, would be to solve the equation. Leave your answer in degrees, in decimal degrees. And so since we're supposed to find theta in degrees, we know that we want our calculators to be in degree mode. And what we'll think here is that if the secant of theta is equal to 1.356, then we know that the reciprocal function, the cosine of theta, is equal to 1 over 1.356, or the reciprocal of 1.356. So using our graphing calculator, what we will do is we'll go second function, cosine, which of course is the inverse cosine function because we use the second function button first. And then to get the reciprocal of this quantity, we'll push 1.356, and then we'll push our reciprocal button, and then of course we'll push the enter button. Let's try that. So let's do second function cosine, 1.356 reciprocal, and then enter. And rounding, we get that theta equals 42.5 degrees. Using the scientific calculator, we'll put the 1.356 in first, we'll get the reciprocal of that by using our 1 over x button. And then to find the angle theta whose cosine is equal to that reciprocal, we'll use second cosine. And of course you should get the very same thing. Now the next thing we want to do is we want to find the other angle between 0 and 360 degrees that has a secant that's equal to 1.356 or a cosine that's equal to 1 over 1.356. And we have to first figure out what quadrant the terminal side of the angle is in. And since this is a positive number, the cosine is positive for first quadrant and fourth quadrant angles. So we know our other theta is a fourth quadrant angle. And of course the 42.5 is the reference angle for that. So when we know the reference angle to find the fourth quadrant angle, we say 360 degrees minus 42.5, and we get 317 and 5/10 degrees. So there are two angles that have a secant equal to 1.356, 42.5, and 317.5. Let's look at this problem 11. Cosecant of theta equals 3.668. The thought will be here that if we know what the cosecant is, then the reciprocal of that angle is what the sine would equal to. So not the reciprocal of that angle, I'm sorry. If we know the cosecant of theta equals 3.668, then we know the sine of theta is the reciprocal of 3.668. Another way to represent a reciprocal instead of 1 over the number is to write the number to the negative 1 power. We could do this or we could do that with it. So to find this theta on the graphing calculator, we'll go second function, sine, and that gives us our inverse sine. And then let's put the 3.668 in, hit the reciprocal button, and push enter. On your scientific calculator, enter your 3.668, hit your reciprocal button, then your second function, and then your sine. And let's see what we get here. Rounding, we get theta equals 15.8 degrees. So it doesn't matter which calculator you used. You should get that value for theta. Now let's find the other angle that has a cosecant equal to 3.668. The cosecant and the sine functions are positive in the first and second quadrants. We have the first quadrant angle. So to find the second quadrant angle, we know that 15.8 is the reference angle of the second quadrant angle. So to find the second quadrant angle, we'll say 180 degrees minus 15.8 degrees, and we will get 164.2 degrees. So let's write that. Our other theta then is 164.2 degrees. Both these angles would have a cosecant equal to 3.668 and a sine equal to the reciprocal of 3.668. Now we have one more problem like this, our cotangent problem. We'll use that reciprocal relationship, tangent of theta equals either 1 over 2.246, or you could say 2.246 to the negative 1 power. That's your choice. On your graphing calculator, second function, tangent, and put your 2.246 in, hit your reciprocal button, and hit enter. For your scientific calculator, you want to put your 2.246 in, find its reciprocal by hitting your 1 over x button, to find the angle whose tangent is equal to this reciprocal. Second function, tangent. We get theta. Actually, rounded to the nearest tenth would be 24.0 degrees. We'll just write the 24 like that. Now, what other quadrant has tangent and cotangent functions that are positive besides the first quadrant? We need to find that third quadrant angle, don't we? So 24 degrees would be the reference angle for that third quadrant angle. And so in the third quadrant, to find the angle, when we know the reference angle, we say 180 degrees plus 24 degrees. And in this case, we get 204 degrees. So our other answer here is 204 degrees. All right, I'd like for us to look at one last problem for this lesson. Use a calculator to find the following. Well, when we write cosine 250 degrees next to cosine 70 degrees, that means to multiply. Then we want to add sine of 250 degrees times sine of 70 degrees. On the graphing calculator, of course, since you've got degrees, you want degree mode. But then you'll push cosine 250. Hit your multiply button, cosine 70, then you'll add sine 250 times sine 70, press enter. On your scientific calculator, you'll need to put your angles in first, 250, then find the cosine of that by pushing your cosine button, times, put your 70 in, and find the cosine of that, plus, now to find the sine of 250, you'll put your 250 in, hit your sine button, times, and then we need to put in the sine of 70. We'll put our 70 first, then we'll hit our sine button, and then hit your equals. So let's see what we get. Did you get -1? It shouldn't matter which calculator you used. All right, I always like to check the keys that I've written down. I like to be sure I didn't leave anything out. But with either calculator, you should have gotten -1. This concludes this lesson. If you're through with the tape, please rewind it before you return it. Thank you.